In today's warm-up question number 1, we're going to be looking at a nested if-then-else control flow statement. Remember, if-then-else statements allow us to write snippets of code that can have different outcomes depending on the conditions of the program when it's running. So if we just briefly break down what we're looking at here, you'll notice that on line 3, we're asking the user to enter some number. And we're converting their string input into an integer and storing it in a variable named choice. So we've declared the variable choice, and that's going to let us know what the user chose as their input. Then we see this nested if else. Right? Now I want to warn you before we look at this more closely, what we see above is that this code listing does contain logical errors. So there's going to be some things that are a little bit strange about this that you wouldn't typically want to do, but I want to give you a chance to think about what that might be before divulging it. Now, if we look at these statements, remember that the tabbing is important. So these lines are trying to tell us something important. So this is the then block of the if statement that begins on line 5, and this is the else block of the else statement that begins on line 10, and those two are related to one another, right? So if choice is greater than 50, will lead to this then block. Otherwise, it will lead to this else block. Similarly with the nested statements. Okay, so what is your challenge here? Your challenge is to try and identify what inputs the user could give in order to have A to print out, in order to have B to print out, C and D. And notice that the way this is written, when this program runs, only one of these letters is going to print out given some input, right? And that's what's kind of interesting about an if-then-else statement. We have a way of sort of having a fork in the road. And here we've got, three forks in the road. Here's the first one, here's the second one, and here's the third one. But before we break this down even further, I want to give you a moment to think about this. So pause the video here and see if you can identify what input, if any, would give you A as the printed outcome, or B, or C, or D, right? And we'll come back and talk about each of these options in just a moment. Okay, so if you weren't able to identify an input that led to each of these letters, that's okay. Not each of these letters can be reached, we would say, given the way this if-then statement is written, because there's some logical errors in it. It is still valid code. The computer is, and the Python programming language is happy to take this program and follow your instruction to the T. And that's why we have to be careful about how we form our instructions. Now, if you want some more time, I would encourage you to, if you didn't pause it before, please do pause the video and try these on your own. You'll get way more out of these exercises that we do as warm-ups and practice in class by trying individually and then checking your work versus just watching the video. And this is especially true come quiz time when we have similar questions like this and we expect you to be able to perform these kinds of analyses. Okay, so assuming you've now paused, tried each of these, try to see if you can come up with each of these, let's break this down. One of the things that I like to use as a tool for thinking through these kinds of relational operators, and especially what outcomes are going to lead to the if side or the else side of these statements, is to use an old friend, a number line. And so if we're thinking, okay, in order for the then block of this to be evaluated, choice needs to be greater than 50. Right? So if we were to imagine a number line like we used way back when, and I'm just going to make 50 the center of this, what we would see is I'm going to use a circle here, an open circle, to indicate not inclusive of 50, because if choice was equal to 50, this would not be true, right? This is only going to be true if choice is greater than 50. And what we're saying is the then block here will be reached for any input that is greater than 50. So 51, 52, 53, and so on, right? And so that's what would send us into this particular area, right? Into this then block. And we see another if statement that says if choice is less than 25. Well, notice that that's already reaching something that feels kind of illogical, right? Because if choice is greater than 50, there's no number that's greater than 50 that's also less than 25. So it turns out we're never going to be able to print A, right? And so if we were to think about, well, why is that? Let's imagine what this looks like. So if I were to draw this similar, I'm just going to break through, and let's imagine 25 is down here. And we're saying, okay, for A to print, choice has to be less than 25. And then you ask, well, where is there overlap, or where are the shared numbers between, what will lead us to this then block and then what will lead us to this inner nested then block? And there isn't any, right? There's no number that's greater than 50 and less than 25. So this is a logical error. No input will lead to A being printed, okay? Now, what about B? So actually, let me bring that back really quickly. I think that's actually a useful little illustration. So let's say 25 is here, and we're not inclusive of 25. So if it's equal to 25, that would be false. And this is the direction we're going. So let me change colors here and say, well, okay, well, how do we get to this else block to reach statement on the statement on line 9 to print B? Well, here's where the number line I think actually becomes most useful, which is trying to remember the rules. Well, how do we invert one of these comparisons? So what's the opposite of being less than 25? Well, that's going to be something that's greater than 25 or equal to, right? So I'm going to fill in this circle so it's inclusive of 25 and it's everything greater, right? Cool. Sometimes if you're like annotating and wanting to just sort of jot down some notes on your code, you might write on a problem like this. If we were doing it on paper, you would say, choice is greater than or equal to 25. And that's what would lead to this else statement, right? So in this inner then, less than 25 would print A, else choice greater than or equal to 25. We'll notice though that because of this outermost if statement, we've got to be a little bit more careful than this, because only really numbers that are greater than 50, right? So 50 was the top constraint. I'm going to get rid of this yellow here. So if I were to draw this line down, it was only 50. It's only numbers that are in this area that would lead to B being printed out, right? So again, that because of this being a somewhat illogically written if then else statement, this winds up being the guiding constraint. And so any choice that's greater than 50 is going to lead to B being printed out. Okay. All right. So let's think about, well, what about C and D and the other side of this if else statement? Okay. And let's give one example of this. So let's try choice 51. So let's imagine the user entered 51 and see what happens. Okay. So we reach this if choice statement. So if 51 is greater than 50, that's true, right? And then the computer is going to come and check this very next condition. If 51 is less than 25, well, that's false, right? So that's not true. So when we reach a false outcome in the Boolean condition of an if statement, we go to the else block, and here we print B. Because we went into this if statement, we're not going to go at all into the else block, right? So that we would skip over this, and then the program would continue on from there. All right. This would be true if we chose a larger number like 99, and anything that we saw on that number line would have been a valid input to get to reach B. Well, how do we get to statements C and D on lines 12 and 14 respectively? Well, we need to do a similar process, but remember, so if choice is greater than 50 is what led to this then block being evaluated, what about choice would make it such that we evaluate this else block? Well, this would be choice being less than or equal to 50, right? So we're flipping this. So it's the opposite of if choice is not greater than 50, then that means it must be less than or equal to 50, right? It's the logical inversion of that. And again, with our number line, if we were to imagine this, just really quickly, this was what we looked at above with 50. And so now if we're thinking, well, what gets us into this else branch? It's going to be, again, 50, but this time 50 is going to be inclusive. So if choice was 50, we would go into this else branch down below. And any number that's 50 or less is entered as our choice is going to lead us to this else block, right? And then we reach another if. So the nested if is to say, okay, well, if choice is less than 50, well, what about if choice is greater than 75? Once again, this is an illogically written if statement. You're never going to reach line C, and we can sort of discern that by saying, okay, let's draw another number line. And what we're saying is 75 and greater than, so I should have drawn that with an open circle, so that's not inclusive of 75, right? And it's all these numbers that are greater than 75, not inclusive. And where's the overlap between numbers that are less than 50 and greater than 75? There is none, right? So you can't, there's no input that will lead to C being evaluated, okay? And what about D? Well, if we switch this would be choice. The else branch down here will be less than or equal to 75. And very similarly to what we saw in this statement above, it would be all numbers that were true for choice being less than 50 are also going to be true for that lead to D being printed, right? So we think about what's the inverse of choice greater than 75. That's choice less than or equal to 75, and that's what leads to D. Let's try this out. So what we're saying is any number less than 50 will lead to D being printed. Is that true? Well, let's try 49, which feels like the closest logical place to check at a bound. And actually, we could try 50. 50 is the logical bound, right? Because it's inclusive of 50. So let's say imagine we entered 50. Is 50 greater than 50? That's false, right? So we skip over the then block. We don't even look inside of it. And we come down to the else. And then we ask, is 50 greater than 75? And that's false. So we skip over this then block and we go to this else, and D gets printed. And we could try this with 0, negative numbers. Any number that is less than 50 or equal to 50 will result in D being printed. So you're probably wondering, why would you ever write an if statement like this that has these sort of branches that are what we call unreachable, logically unreachable? So A, there's no input that you could enter to give you A, and there's none that could give you C. Well, you shouldn't write code like this. If you have unreachable branches in your code, there's probably a logical error in the way you were thinking about it, and that's not good. So this type of analysis to think through, okay, is what I'm trying to express actually represented here? And in this case, the answer is probably not, right? So in this case, what if we wanted A to be printed? Let's imagine what we were trying to accomplish here was A was for numbers less than 25, B was for numbers greater than or equal to 25, and less than 50, right? And then C, say, was for, let's imagine that we wanted something kind of strange here. C was for numbers greater than 75. And D would have then been, let's say, for greater than or equal to 50 and less than 75 or equal to 75, right? So the question is, could we implement logic that actually has these qualities? And the answer is absolutely yes, you could. And that would be a great exercise for you to do. See if you can write an if then else statement that implements this logic. And what we'd like you to do is, at this point, try pausing the video and writing an if then else statement that does implement this logic, and see if you can do that, right? We'll come back here in just a moment with a solution or a potential solution to that. There are going to be many. Okay, so if you go ahead and open up VS Code and you have a file, I named mine if then x or example .py with dashes between the if and the then. You can name your file whatever you'd like. You can put it in your lessons directory or anywhere else in your VS Code workspace that makes sense to you. I added just a simple doc string, and then here's where we're making our choice and asking the user for some input. We're then implementing some logic, and I've reconstructed, what letter we want printed as output and the conditions under which we want that letter to be printed for the given choice. Okay, so if you want to pause here, and if you didn't make it this far before, and just try writing the if then else statements to make this actually be the case, go for it. All right. So if choice is less than 25, then what we want to do is print A. right? And so that successfully captures this first piece of logic. Otherwise, if choice is not less than 25, if it's greater than or equal to 25, which captures this. So we actually aren't even going to write this expression, is choice greater than or equal to 25. And let me write the words when here. That makes this a little bit more obvious. So implement this logic. Implement the logic to print A when choice is less than 25, B when, and so on. Okay, so we add our else statement, and otherwise that's going to capture this part of the second clause here. So if choice is less than 25, we print A. Otherwise, that means choice must be greater than or equal to 25. Then what we're going to do is another if. So we need to be sure that, choice is less than 50. So if choice is less than 50, we'll print B. Right? Otherwise, and so now where are we at? Well, so choice is, if choice was less than 25, we would have printed A. We would have skipped over everything else. If that wasn't true, choice is greater than or equal to 25. But if it's less than 50, then we're going to print B. Otherwise, if choice is greater than 75, so if choice is greater than 75, then we can print C. Otherwise, we can print D. Right? And now we've got this logic. I'm going to just try and bring this up so that everything can fit. 1 second. Okay. And it doesn't look like there's a one-to-one match with all of these relationships, right, between the code that we have down here. But if we think logically through this nested if-then-else statement, there are two important things to recognize. Some of these conditions are implicit in the logic of the if-else, right? So if choice is less than 25, if that's true, we print A. Otherwise, we know that choice must be greater than or equal to 25, which captures this logic. The same would actually apply to D, right? So D, just by necessity, if choice is less than 50, well, that's not true. So we go down to this else, and we would see, okay, well, it's got to be greater than or equal to 50. So that condition's true. And less than or equal to 75, well, that becomes true by the inverse of this greater than 75. We'll see in just a moment. I'm actually going to say that this is still, this logic could be improved a little bit further to try and make it easier to reason through the logic, because once we get down to C and D, that's a little bit harder to reason through for reasons we'll see when we bring back our number line. All right, but we could try this out really quickly and just convince ourselves. So I'm going to run my program, Python M, and then again, because I named my file if then x and put it in the lessons directory, the module is lessons.if then x, and we're asked for a number, and I enter a number like 24. We expect that to print A, and it does. We are asked to enter a number, and now let's test for, what about 49? That should print B. Sure enough, it does. What about a number that's greater than 75? Let's try 76. C, and then, of course, if we looked at our logic, greater than or equal to 50 and less than or equal to 75, we could try 50, and we would get D. We could also try 75, and we get D as well. So it looks like this logic is working. And if we just take one more moment, let me clear out the annotations I had before to sort of try and reason through and break down why is this the case. We can go back to our number line, and we can kind of see, okay, 25 has A covered, right? So this area is going to lead to A being printed, okay? Well, what about, let me change colors here. What about for B, right? And so with B, what we're saying is choice is less than 50. But it's not only that, it's also the opposite of whatever A was. So it's going to be, okay, well, it's going to be everything including 25 and heading this way. But also there's this constraint less than 50. So if I drop 50 right here, it's going to be this segment on the number line is what will lead to B being printed, right? And if I change colors one more time, and we imagine 75 is right here. Oops. And everything greater than 75 this is going to be true for, okay? So it's all the numbers over here will be led to D being printed. And lastly, if we were to imagine for D, how do we know where this goes otherwise? Well, we've got these two constraints, right? So if choice is less than 50, else it's going to be everything that is greater than or equal to 50, right? So inclusive of 50 in this direction. But because the if statement was choice greater than 75, it's going to be less than or equal to 75. So it would also be inclusive of this, so 75. And this would lead to C being printed. Now, if you're thinking this part is kind of confusing to logically reason through, I would agree with you. And this visual kind of gives us a hint as to why that is. Notice there's like this real nice relationship between how A and B are printed, and this is expressed. And it's kind of like we're walking down some stairs, or there's this like natural relationship between them. Okay, we've got the range from less than 25 for A, and then 25 to 50 for B. But then there's this gap, and D like kind of jumps somewhere else, and then we fill in that gap with C. Oops, I mislabeled these. Sorry, let me go back. Really sorry here, mislabeled these. So this third line should have been C, and this fourth line should have been D. My bad on that, right? So there's this gap in order for us to print C, and then D is, almost like it feels like a step back. So could we rewrite these lines to fix that, to still have the same outcome where C is still going to be printed if choice is greater than 75, but we wouldn't have this sort of, it would be easier to read logically. And the intuition here is going to be, well, yeah, we can, because right, you can flip any if then else statement and have what comes in the else happen in the then if you flip this condition so that it's the opposite, right? So what we learned before was if choice is greater than 75, that's going to lead to printing C. Otherwise, if choice is less than or equal to 75, that's what's going to lead to printing D. So what we could do is we could write, instead, if choice less than or equal to 75, then what we're going to do is print D. Otherwise, print C. All right, so let's go rewrite our code like that and convince ourselves that this makes it a little bit easier to reason through. Okay, so if choice is less than or equal to 75, print D, otherwise print C. So now this is kind of funny because, D is being printed as an output before C. But again, we're really just trying to think about how might we express logic that pertains to particular bounds. And otherwise, this feels much more logical, right? So if choice is less than 25, we print A. Okay, if that's not true, then we're going to have to test is choice less than 50, and we'll print B. Okay, if that's not true, we'll test if choice is less than or equal to 75, we'll print D. And if that's not true, that means choice is going to be greater than 75, and we'll print C. And so notice that what we've done here is we've taken an illogically written if-then-else statement with nesting and sort of reworked it by moving around how these nested statements relate to one another. And notice how we can be creative with how we express what comes in the then or the else. We can swap around the logic of one in order to flip what would be in the then block and the else block. And this leads to a much easier to reason through program. There's one other thing I want to point out, because this is going to become important when we learn something called the elif statement, which isn't going to give us any new features, but will give us some code that's a little bit easier to write. So notice that as we're writing this, the level of indentation gets pretty deep, like we're 3 levels deep for these print statements. And if we had, print E, F, and G, we would have needed even more indentation. But this pattern here of saying, okay, if one thing's true, do something. Don't put another if then inside of that necessarily. Otherwise, do something else. And in that something else, we're going to check, okay, what about if this is true? Otherwise, if something else is true. Otherwise, if something else is true. Okay. And so this pattern of testing for one thing, having a simple then statement, and then in the else block, performing other tests that are related to that first one, is much easier to reason through than what we were trying to do up here, where we had an if statement, and then in the then block, there was another nested if then statement, and so on. Okay. All right. So let's just try this with one input here, and let's pick a number like, say, 51 and convince ourselves that this actually does work as we intended. So 51, we entered for the choice less than 25, so 51 less than 25, that's false, so we would go to the else. 51 less than 50, that's false. 51 less than or equal to 75, that's true, so we would print D and we would skip over this else block. Let's try one more to just be sure that we understand how this works if we chose a number like 24. So if 24 is less than 25, that's true, so we would print A, and because all of this is in the then block of that if then else statement, we would skip over it, and that's all that would get printed. All right, so this is some practice with if then else statements and nesting. And these are important concepts to be comfortable with as we're moving forward.